Dear students, in this presentation, we'll see one more machine learning algorithm, which is very beautiful and very useful also. That is decision tree learning. This decision tree learning is a widely used predictive model for supervised learning. That means you should define the classes, you should have the class structure, the target value should be defined properly. Once a decision tree is constructed, it is easy to predict the class or the value. This is somewhat derived from the binary tree kind of structure, but not exactly binary tree, more or less similar to binary tree. This is used for both classification problem as well as for the regression kind of problem also. The decision tree model basically represents logical rules that predict the value of a target variable by inferring from the data features. You will be given data sets and the target value also, some of the logical rules. Based on logical rules truthness, we will be deriving the fact. Decision tree learning model classifies data instances with high accuracy and consistency. And here we follow some mechanism called entropy or the information gain or Gini index that indicates how certain the data the rule is. Decision tree is a concept tree which summarizes the information contained in the training data set in the form of tree structure. Once this tree is built, then test data can easily be classified. Decision tree learning algorithms that can perform classification, regression task, even multi-output task also. This is a background for another beautiful concept called random forest. Decision trees are often used while implementing machine learning algorithms. This follows a kind of hierarchical structure where one of that node is called the root node. Then, based on the logical rules, the tree is split into right, left, middle, child, like that. Or in general, tree is split. When you are deciding to split the tree, again you have to choose who becomes the next parent, the next generation parent, like that. So there are concepts, those helps us to measure which is the root or to split the tree. These are Gini index and information gain. For both of that, the entropy calculation is also required. The entropy that measures the impurity, okay, which is almost in all the field, this entropy calculation is used. The structure of decision tree. A decision tree structure that consists of a root node, which is the topmost root node in the tree. Then we have got internal nodes. They may be parent node. We can say those are all the decision nodes, or also called test nodes. Then, based on the truthness, it can be true or it can be false, it can be that case or that can be other case. We have got branches. Like that, tree grows and ends up at the final external node or terminal node, also called leaf node. A test node represents a choice, that a decision node, which looks like our flowchart symbol decision. Root node usually indicated with a circle. Decision, these are all the symbols that are used to indicate the topmost node, the decision node, and the leaf node. Test node represents the choice or test of an input attribute, and the outcome or the outputs of the test condition are the branches originating from this decision node. The branches are all labeled as per the outcomes or the outputs values for the test condition. Values of the test condition. Either it goes to one side of the branch or it goes to the other side of the branch. Every path from the root to leaf node represent one certain logical rule which corresponds to congestion of test attribute. A circle is used to indicate the root node. Diamond shaped symbol is used to represent the decision node, and the internal node, or the square rectangle is used to indicate the leaf node. Now, very important part here is to construct the tree. How the tree is constructed, that is building the tree. The goal is to construct the decision tree from the given training data set. So this is always constructed like a top down approach. First you have to decide the parent, next decision, next branches, like that it goes and ends at external node or the terminal node or the child node. It starts always from the root. At every level of construction, we need to find best split attribute or the best decision node. Who can make the decision? The parent node or the root node based on the attribute given in the data set. This is a recursive process. So by doing this many times, we get the complete data set in the form of tree. From that tree, we can make a prediction or we can decide class. From this, again, once the tree is constructed, it is easy to judge, easy to predict the given condition. The advantages, it is easy to model, simple to understand, input and output attributes can be discrete or even can be used for continuous predictor variables. Model a high degree of nonlinearity in the relationship between the target variables and the predictor variables. In such case, tree can be used, easy to train. Like any other algorithm, this also has certain disadvantages. It is difficult to define how deeply a decision tree can be grown or when to stop. Manually, if you are doing little tedious task, if training data has error, it will mislead. It is propagated later, or you will not get the proper tree. If the training data has continuous valued attributes, it is difficult to handle mathematically or computationally little complex. Complex tree may also be overfitting with the training data, underfit. There are all the difficulties that we observe in the training data set. Now, how these attribute looks and the value looks like. We'll take a simple case of student performance and in the exam. A class attendance has varieties of values like good attendance status, average or poor, assignment, good quality assignment, moderate or poor, the homework assignment like submitted or not, assessment like good, moderate or poor, participation in competitions or other events, maybe, may not be, yes or no, group activities such as projects and presentations, yes or no, exam result. Based on this, you will be deciding, supervising exam result, pass or fail. Let us take one simple example. You are given a table like attributes are assessment, assignment, and exam results. Assessment, the mark is more than or equal to 50 or less than 50. Assignment, if suppose assessment mark is less than 50, then you check the assignment. If submitted, then pass. Otherwise, fail. This is the rule. If assignment mark is greater than 50, you declared student as pass. If assessment mark is less than 50, then check assignment. If submitted, declare pass, otherwise fail. Now, to get a tree, The one factor that rules dominates is assessment. So that will be placed at the top. This is easiest one, but when you solve, this method is not at all useful. So you will be keeping that as a root node, assessment as the root node. If assessment is more than 50, declare student as pass. If assessment is less than 50, check whether assignment is submitted or not. If submitted, declare student as pass, otherwise fail. So all the ingredients are there. There is a root node, assessment. There are three terminal node, pass or fail, and there is one decision node called assessment. There are two branches called uh, assignment submitted yes or assignment submitted no, like that. Assessment is more than 50 or less than 50. So for any given value from this tree can predict. The main the work depends on important technical factor called entropy. For the given training data set with a set of attributes or features, the decision tree is constructed by finding the attribute or the feature that best describes the target class for the given instances. The next question rises here is how to split this data set. Who can be the parent? Who can be the root node? Which side, when the rule is satisfied and reaches where? All these plays important role. For our study for this decision tree, a concept is borrowed, that is Shannon entropy, which is calculated based on the probability distribution of the event. So entropy is the amount of uncertainty, amount of randomness in the outcome. Like when you toss a coin, there is a guarantee that either head will come up or tail will come up. But when you toss a dice, the chances are more. Like it can be one, it can be two, or it can be three, like that. Okay, the occurrence of event, the probability that is used here. Entropy describes about the homogeneity, purity of the data instances. The best feature is selected based on the entropy value. Higher the entropy, higher the uncertainty. Lower the entropy, lower the uncertainty. For example, if there are two classes, pass, fail, yes, no, true, false, these are the true classes. Suppose the one class, true classes has the entropy value 1 and the other one is 0, which means that the one positive class is homogeneous, negative class is not there. In this case, entropy value is 0. In the other version, if the positive class is 0 and the negative class is 1, in that case also entropy is 0. So entropy value, without calculating, we can substitute that value 0 if nothing is there in one class and full from the other class. Suppose equally distributed, 50% positive, 50% negative. In that case, entropy value is 1. In all other cases, purity is mixed with impurity. The value ranges from 0 to 1. This is depicted in the form of graph. You can see here, this is the way. If all of negative classes are positive classes, then entropy value will be 0. If it is 50% positive, 50% negative, can see here, all negative classes 0, all positive classes 0, 50% positive, 50% negative, then entropy is 50%. Entropy value is 1. In other cases, the purity may be high, impurity may be high. In these cases, plus indicates the pure and minus indicates the impure. Sometimes purity may be less or it may be more. So this is how to remember the entropy relationship with the purity. Suppose there are classes like n classes. The probability distribution is from P1 to Pn. The entropy of this whole P computed as entropy of P1, entropy of P2, entropy of P3, like that. Sum of all the entropy of these information. That is the total entropy. Total entropy is the summation of entropy of each of the information. That each information, each probability, each event or that computed as minus P1 into log base 2, minus P1 into log base to P1. So don't forget to put the negative sign, like that. Summation of everything, minus of summation of Pi log to Pi. Okay. So what is that P? P is the probability, that is number of data instances belongs to that class, say one class, divided by total instances. For example, if there are 10 data instances, out of which 6 belongs to positive class and 4 remaining negative classes, the entropy is calculated as entropy equal to minus of sum of 6 over 10. 6 is the positive instance, 10 total, log 2 6 by 10 plus other one negative class. Here there are 2 classes, so only 2. If there are 3, then you have to sum all 3. If there are 10, you have to add all the 10. We'll see that in the problem. 4 divided by 10 log 2, that is 4 by 10. This is the entropy. Okay. The Gini index or the Gini impurity, which measures the degree or probability of the particular variable. So this index varies from 0 to 1. 0 indicates that it belongs to one certain class. 1 indicates that randomly distributed across various classes, impure. Okay. So Gini index 0.5 denotes equally distributed elements in some classes. Information gain is one more term that comes here. Information gain is used to determine which feature or which attribute gives us the maximum information about the class, which decides about the class. Information gain is based on the concept of entropy, which is the degree of uncertainty or degree of impurity or degree of disorder. It aims to reduce level of entropy starting from the root node till the leaf node. Once you reach leaf node, that finishes the work. Relevance of entropy. Entropy is a measure of disorder, measure of impurity in the data set. Gini index is a tool that aims to decrease the level of entropy from the data set. So it is the measurement of impurity. Can see that in the graph. Probability is from 0 to 1. Entropy is also from 0 to 1. If all belongs to one class, positive or negative, the entropy value will be 0. If equally distributed, then it is 1. So entropy computed as sigma of minus Pi log to Pi. Gini index is computed by subtracting that entropy from 1. Gini index equal to 1 minus sigma probability square. We'll see that in the next session. These are the various decision tree algorithms: ID3, C4.5, CART, CHAID, Quest, Void, Cruise, C3. The commonly used are ID3 and CART algorithm. C4.5 is advancement of ID3. CART is for classification and the regression tree. The difference is that ID3, C4.5 and CART algorithm used in the construction of decision tree usually. ID3 uses information gain. C4.5 uses gain ratio. CART uses Gini index. So ID3 C4.5 uses univariate. CART algorithm is for the multivariate. All these you can see. Now we'll take one simple problem. It takes time. This is the data set given. This is the data set given. Okay. Serial number, CGPA, interactiveness, practical knowledge, communication skills, and the job offer. Target column is the job offer. There are 10 rows. Out of the 10 rows, there are 1, 2, 3, 4, 5, 6, 7 instances of yes and 3 instances of no. 7 yes and 3 no. You can see here 1, 2, 3, 4, 5, 6, 7 instances of job offer yes and 3 no. First step is to compute this target attribute, that is job offer entropy. There are 7 positive, 3 negative. Minus 7 by 10 log 2 7 by 10 plus 3 by 10 into log 2 3 by 10. Use log 2, that value you will get the final answer as 0.8807. This is the entropy of the target. Next, we have to decide out of other attributes which can be the root. By looking to the data set, we can't tell. You have to take each and every how that is related, CGPA or interactiveness, how that is related. Now we will take CGPA. In the data set CGPA column, there are 3 different varieties of data, possible values: greater than equal to 9, greater than equal to 8, and less than 8. There are 3 different possibilities. In interactiveness, yes and no. Practical knowledge, very good, good, and average. In communication, good, moderate, poor. These are the different possible values. Now we will take one by one. CGPA job offer, interactiveness job offer, practical knowledge job offer, communication skill job offer. Whichever the value that is of higher, that is the root. Now we have finished first step. Now CGPA and job offer. CGPA, there are 3 different cases: greater than equal to 9, greater than equal to 8, less than 8. Job offer yes, how many? Job offer no, how many? Then add the total, then entropy. Okay. Now CGPA greater than 9, from the data table there are 3 job offer if CGPA greater than equal to 9. CGPA greater than 9 and there is only one no job offer. Okay. Total 3 plus 1 is 4. Total 10 you should get. Greater than equal to 8, there are 4 job offer yes, there are 0, there is no 0 job offer, total is 4. Less than 8, no job offer is 2. Okay. So as I told earlier, if positive or negative is 0, entropy will be 0. Positive or negative, that value is 0, that entropy will be 0. So anyway, you have to compute the entropy of this information. Here CGPA is the information on total. Okay, row by row you have to proceed. 4 out of 10, 4 by 10, P, 4 by 10 into minus 3 by 4, yes job offer, 3 by 4, log 2 3 by 4, negative, minus 1 by 4, log 2 1 by 4. This is for greater than equal to 9. Next, greater than equal to 8, greater than or equal to 8. There are 4 out of 10, greater than equal to 8, 4 by 10. In that, 4 yes, 0 job offer no. Last, less than 8, there are 8 here. There are 2 over 10, 0 by 2 log 0, and like that. Anyway, as I told, one of the class is 0, you can directly substitute that as 0. So you are left up with only one, that you compute it. You will get 0.3243. Information gain of CGPA is subtract the total and this one. Earlier value we got 0.8807 minus 0.3243, value is 0.5564. We got CGPA. Now we have to go for the another information, that is interactiveness. There are 2 possible values, yes and no. Yes and job offer yes, job offer no, no job offer yes, no job offer no. From the table you substitute the value. There are 5 job offer yes for yes, interactiveness. There is only 1 job offer no for yes. There are 2 job offer yes for interactiveness no. There are 2 instances job offer no for interactive no. So total of 10. Entropy you can't directly substitute because you have to compute. So there are 6 yes out of 10. There are 4 out of 10. In that 6, 5 positive and 1 negative. 5 over 6 into log 2 5 over 6 minus 1 by 6 log 2 1 by 6. 4 by 10 into minus 2 by 4 log 2, like that you have to compute. Compute the value, you will get value 0.7896. Subtract it from the total. Earlier we got that total 0.8807 minus 0.7896, that is 0.091. So we got information gain for the interactiveness. Similarly, you go for one more, that is information on practical knowledge. There are three different types of values for practical knowledge: very good, average, and good. Average good, there are two instances of job offer yes, zero instance of job offer no, total 2. Average, one instance of job offer yes, zero, two instance of job offer, two, total 3. For good, there are 4 instances of yes, 1 instance of no, total 5. So now you have to compute everything. There are 3. For the first one is very good, second is average, third is good. For the first one, there are 10 instances. In that 2 very good. There are 10 instances. In that 3 average, 5 good. In that 2 positive 2 negative 0. So entropy is 0. In the average, there is only 1 positive and 2 negative. In the last one, 4 positive, 1 negative. So here you can't directly put the value to compute it. After computation, you will get 0.6361. Subtract it from the total 0.8807. You will get 0.2446. So you practice it and try. Next is communication skill. There are 3: good, moderate, and poor. There are 4 good, 4 job offer yes for good. There is only 1 job offer no for good, 3 yes for moderate, 0 for moderate, no, like that. So all the values from the table only. Again there are 3 possibilities: 5 out of 10, 3 out of 10 is moderate, and 2 out of 10 is poor. In that 5, 4 positive class and 1 negative. In that 3 positive class, 0 negative. This you can substitute to 0, and the last one is also 0. So you left up with only one, the first part, substitute it, you will get value 0.3609. So subtract it from 8813, that is 0.5203. Hope you have computed everything. The last part here is that you decide which is the root. In this, bigger value to choose. CGPA is having highest gain, so that becomes a root, like this. In that there are 3 branches: greater than equal to, less than equal to, like that. So if less than 8, job offer is no. If greater than 8, no confusion at all. CGPA, if CGPA if it is 8, you can refer the table. If it is less than 8, there is no job offer. You can directly write. So you ends up with the leaf node. If greater than equal to 8, there is a job offer. If it is 9, again it depends on. You can't tell directly from the. I'm getting this from the table only. If it is greater than 9, you can't tell job offer whether it is yes or no. You can see here. See, if it is greater than 9, job offer might be yes, might be no. So you can't decide. So again you have to repeat the step to get the parent here in this part. Same. Okay. Now you can see that in the diagram. Wait. So it depends on interactiveness, practical knowledge, and communication. 3 times you have to repeat. First, job offer as usual. In that, interactiveness job offer, practical knowledge job offer, and communication job offer. Okay. So this you have to repeat it. This you have to repeat it. After repeating, anyway, you refer the slide. After repeating, you will get here the attributes interactiveness and practical knowledge, communication skill. In this, practical knowledge and of same, so it decides. You can take the decision, practical knowledge, if it is good, average, or what is the things. So this is the final decision tree. I will be sharing the question later. First you listen till Sunday, then on Sunday I am going to share the question. Okay, thank you.